Hi, we are going to talk about the synchronous transfer mode, ATM. The exhibitors are Henry Peña, Vladimir Mendoza, and I, Jenny Gonzalez. ATM is a switching technology that uses small, fixed-size cells. In 1988, the CCITT designated ATM as the plain transport mechanism for the use of future broadband service. ATM is asynchronous because cells are transmitted over a network without having to copy specific bits of time in packet alignment, such as T1 frames. All types of information are segmented into fields of small 48-byte blocks. The remaining 5 correspond to a header used by the network to move the cells. ATM is a connection-oriented technology in contrast to the LAN-based protocols, which are offline. Once the connection is established, the ATM cells are auto-routed because each cell contains fields that identify the connection of the cell to which they belong. The ideal environment in which to use ATM is one that combines computer, voice, and video networking into a single network, and the combination of existing networks into a single infrastructure. Asynchronous transfer mode is one of many network transmission protocols, including Windows Server 2003. The most commonly used transmission protocol, including Windows Server 2003, is TCP/IP, which is a connectionless protocol. As such, TCP/IP can offer some of the advantages that a connection-oriented virtual circuit packet switching technology such as ATM can. Unlike most connectionless networking protocols, ATM is a deterministic networking system. It provides predictable, guaranteed quality of service. In the image, we can see that sends packets of 53 bytes called cells. The small size of the packets guarantees a minimum delay while an increase of overhead. The smaller the package, there are more headers, proportion, and loss of bandwidth. The advantage obtained is low latency asynchronous data transport that allows efficient switching hardware and thanks to the constant packet size. The characteristics of ATM are high bandwidth capacity, support for both LAN and WAN traffic, use the virtual network concept, supports both point-to-point and multi-point transmissions. It can send a large number of types of traffic on the same network infrastructure, and it's flexible in terms of bandwidth. Architecture of ATM. ATM is a combination of hardware and software that can provide either an end-to-end network or from a high-speed backbone. The structure of ATM and its software components comprise the ATM architecture as the following illustration shows. The primary layers of ATM are the physical layer, the ATM layer, and the ATM adaptation layer. Now, the function of ATM adaptation layer is that facilitates the use of packets larger than a cell. Packets are segmented by the ATM interface, transmit individually, and they resemble on the receiving end. The ATM adaptation layer includes the segmentation and reassembly and convergence sublayers. The function of ATM layer is that regulates cells and cell transport and establish and release virtual circuits. The ATM layer has no sublayers. And finally, the function of physical layer. That layer represents the physical medium and regulates physical layer functions such as voltage and bit simming. The physical layer consisting of the transmission convergence and the physical medium depends on layers. In the picture, we can see a structure of layers of ATM. First is ATM adaptation layer with sublayer CS and SAR. C is handling less, theming recovery, and interleaving. And the is AR sublayer split frames and reassemble frames. For the ATM layer has function like cell routing, multiplexing and demultiplexing, and generic flow control. And finally, in the picture we can see physical layer with TC sublayer, that cell header verification and cell delineation, rate decoupling, transmission frame evitation. And pH, that is the sublayer that bit theming and physical medium.
AAL layer. ATM adaptation layer adapts each traffic to its initial velocity, segmenting and reassembling the information into pieces 48 bits, detects errors or missing cells, and maintains synchronization between connected users. The medium adaptation layer AAL provides the conversion into cells of the different types of packets necessary to accommodate the mixing of data types in the same network. The AAL performs the function of segmentation and reassembly that components the information of the layers of higher levels. It also manages time control of transmissions and handles loss of incorrectly sorted cells. The image shows in more detail by means of diagram the composition of the adaptation layer, starting with the type of service, which is divided into AAL1 and AAL2, AAL3, AAL4 and AAL5, of which AAL1 and AAL2 have teaming relationship. This bit is more constant and connection oriented, while AAL3 and AAL4 and 5 have byte rate variable and connectionless. Likewise, the sublayer CS and SAR divided in SAP1 and SAP2, timers and sales loss recovery managers SAP3 and A3, port and ASP5, responsible for cell loss detection. ATM layer. The ATM layer is the actual core technology. It deals with adding and removing headers, keep the connection indifferent for routing between nodes, and multiplex and demultiplex cells through the physical environment, maintaining the connect sequencing of cells. The image is format of the ATM cells. The first 5 bytes are the general flow control, virtual path, identifier, virtual channel identifier, payload type, cell loss priority, and header error control. The other 48 bits corresponding to the user information are composed of payload. Model ATM. The different functions of the ATM architecture are distributed in the layers that allow better management and convergence of all its functions. For data flows are identified for civil AAR are constant data bit stream or CBR, flow variables of data bits or BPR, connection oriented data packets, offline data packets.
The physical layer is a set of rules regarding the HW that is used to transmission data. Among the aspects covered in this level are the voltage used, the transmission synchronization, and the rules to establish the initial grading of the grade communications connection. This ATM physical layer has the following functions: converts bits and in the next image sends packets of 53 bytes called cells. The small size of the packets warrant a minimum delay while an increase of overhead. The smaller the information reads a terminal node, ATM is captured, segmented, and arranged in cells suitable for each type of traffic handlers. This service provided by the AAL called QoS level is defined by three parameters. Flow defines the volume of information that can be sent over a period of time. Is traffic constant? The parameter is unique. Peak velocity, but is traffic is bursty? It is expressed by three connection parameters. Peak speed. The advantage of the ATM network are: a single ATM network will accommodate all types of traffic. For example, voice, data, video, and improving the efficiency and management. The disadvantage of the ATM network are its cost, replacement of